Hey guys, welcome back to my channel. Thanks for clicking on one of my videos. In this video, we're going to be talking about bubble sort, and bubble sort is uh, is one of the basic things that we need to understand about sorting, right? Yes, I agree that it's not the best type of sort that's out there, but you know we all start from the basics, so right? So let's understand bubble sort. Let's jump right in. So the question is, obviously we're given an array and we are supposed to sort it, and we're going to use bubble sort. So this video is a little different because usually I start with my programs and I try to explain my program and then the output. So we're going to do the reverse this time. So this time we're going to see how the sorting really happens, and then we'll go back and look at the program, right? And then towards the end of the video we'll talk about the time complexity and probably space complexity as well, right? So okay, so let's go ahead. So this is the array we're given, right? So this is the array I took that I'm going to be sorting. um, so what we do is we basically we iterate over this array, and this array contains like 7 elements: 1 2 3 4 5 6 7. So we're going to be iterating this array 6 times, and then each time what we're going to do is, well, let's jump right into the first iteration, and that way you can understand what we're going to do, right? So the first iteration, what we'll do is we'll start with the index position 0, right? And then we'll just compare this value with the value in the next position, and then if this value is greater than this value, if the value in the 0th position is greater than the value in the first position, we're going to swap. In this case it is. So that's the first step actually. So we're going to compare this one and this one, and if 19 is greater than 3, we're going to swap, but 19 is not greater than 23, so we're going to leave it as it is. So then we move the pointer to the next position, which is 23 now, and then we're going to compare 23 with 10. Is 23 greater than 10? Yes, so we're going to swap. So that's what we're it says here, right? So then the array is going to look like this, and then we're going to move our cursor to the next position, and then compare this value with the next value. Is 23 greater than 19? Yes, so we're going to swap the values, and then we're going to move the cursor to next position. Is 23 greater than 60? No, no, so we don't swap. So we move to the pointer to the next position. Is 60 greater than 87? No, so we just move the pointer to the next position. And is 87 greater than 32? Yes, so we're going to be swapping 87 and 32, right? So now after the first, so we're going to stop here. We're not going to move to the next index position because there's nothing to compare it with, right? So, and then now we can see that like 87 is here and 32 is here. So after the first iteration, the biggest number, the biggest element in the array has been brought to this last position, right? And if you think about it, like so this is an element, this is an array that contains 7 elements, and then we had to do 6 comparisons. 1 19, we had to do 6 comparisons, which is what is shown as the step numbers here, right? So the step number 1 is we're comparing 19 and 23, and then the value in this position, that's the second, and then third, and then fourth, and then fifth, and then sixth. So we did 6 comparisons, 6 steps. So step is nothing but the number of comparisons we're doing here. So next iteration. So the next iteration, we basically start from the zeroth position again, and we do the same thing. So we compare 19 and 10, and then if is 19 greater than 10, yes. So we're going to swap 19 and 10, and then the same thing. There's 19 greater than 10 here. So again, the next comparison is 19 greater than 19, and so on. So we keep doing that, and we do the second iteration, right? But in the second iteration, one key thing to note is that we do not compare. We know that the biggest element in the array has been brought to this position after the end of first iteration. Now in the second iteration, we don't go till here and compare it with this guy. We only go till this position, right? Because when we are in this position, we compare it with this position, and then the biggest number will come here, right? The biggest number, of course, is 60, right? The 60 comes here. So the second iteration, we only did 5 comparisons, and totally we did like 6 comparisons in the first iteration and 5 comparisons in the second iteration. So in the third iteration, we're going to be doing 4 comparisons. So you can see that total number of steps we had taken by the end of the previous iteration is 11. The total number of steps we had taken, or the comparisons we have done in by the end of third iteration is 15. So 6 comparison in the first, 5 comparisons in the second iteration, 4 comparisons in the third iteration, 3 comparisons in the second iteration. I'm sorry, 3 comparisons in the next iteration, and then 2, and then 1, and so on, right? So that's basically how this bubble sort works. So at the end of so we have 7 elements, we do 6 iterations, and we keep sorting it over and over again. Like we iterated like 6 times, and we compare, and each time we compare one time less, right? One time less than the previous iteration, and finally we end up with an array that is sorted, right? So if you look at the time complexity, like before we jump into the program, if you look at the time complexity of this sort, like the first time we did 6 comparisons, right? We went all the way till the end, not the last number, the last but one. So that is n minus 1. Like we did 6 comparisons, but we have 7 elements in the array, so 7 minus 1, 6. The next time we did 5 comparisons, next time we did 4 comparisons, and so on till we did 1 comparison in the last iteration, right? So what is the total number of like comparisons we had to do? It's this basically, right? If n is the number of elements in the array. So now if like the formula that we talked about in one of my previous videos, the prime number video. So if you want to add up a sequence, like let's say 1 2 3 4 5, so the sum of the sequence is n into n plus 1, n into n plus 1 by 2, right? So let me just type that here. Sum of a sequence which has n values is n times n plus 1 by 2, right? So, and this one looks like a sequence, like it starts from 1, it goes till n minus 1. So if you apply the same formula here, so then it'll be like n minus 1 plus 1 is n, so n minus 1 times n by 2, right? And then this comes something, if you try to evaluate the expression and do the math, it becomes like n square minus n, and divide the whole thing by 2, right? As we have seen in one of my previous videos, where I talked about big O notation. So like when we are trying to calculate time complexity, we always tend to look at the asymptotic analysis, right? So asymptotic analysis is when basically n tends to infinity, we start like ignoring, or we only consider the significant terms. So in this case, actually n square is more significant than n itself. So the big O notation of this algorithm is n square, right? So which is why we say like this bubble sort is not not the kind of sort that performs the best, as opposed to a merge sort, or yeah, as opposed to some of the faster sorting algorithms out there. But yeah, so that's the algorithm, and that's how bubble sort works. And I'll quickly show you my Python program, to show you how I did it, right? So all I have is, this is the main section of the program. So I started with a list. We don't have an array like we do, array data structure like we do in Java. So we have a list, and I'm just calling this function called bubble sort, and then I'm passing in my list, right? And this list basically, what we do is, so we take that and we see how many, we count the number of elements in the list, and then we have one for loop. Like we have a bunch of other things. It's just uh, so I wrote this function called display list to display my list like an array, like this. That way it's easy to explain for you guys. And yeah, so if I have a for loop, right? I have a for loop, and then I have another for loop inside that for loop. So in the basically I have a range that goes from 0 through n minus 1, which is, like in this case, n is 7, n minus 1 is 6, right? 0 through 6. And then each time in the next for loop, what I do is I go from 1 through, like in the first iteration, I'll go from 1 through n minus 1, yeah, n minus 1 comparisons. The second iteration, I do n minus 2 comparisons, right? The comparison is being done here, right? So where if j is 0, if j is 0, and I take that value, and if j is 1, I take that value. So I just compare uh, the values which are next to each other, right? I basically compare one value with the value that is next to it, right? And that's the comparison I'm doing. And if if this guy is greater than this guy, we swap, and the swap is done uh, kind of like in a better way in Python. In Java, we would have like a temporary variable, right? Because if we are swapping, let's say like values a and b, so we cannot just say like a equals to b and b equals a in most of the programming languages. So we need to like assign, let's say, a to a temporary variable called temp, and then we assign b to a, and then we assign um, the temporary value, the value in the temp variable to b, and that's a we swap. So we need a temporary variable. So in Python, what we have is we have this dynamic way of assigning variables. So we just say, so j equals j plus 1. We're swapping the value from the next position into j, and then we're swapping the value in this position into next position at the same time. So that's one good thing in Python. And finally, I'm just doing some displays and so on. And I have like a counter here to show you like how many times I'm doing comparisons, how many times this internal loop is getting executed. So we did totally 21 steps here, which is basically like so if you look at it like according to our formula, so n times n minus 1 by 2. If n is 7, in this case it is 7 times 6 is 42 by 2 is 21. So we did 21 comparisons, 21 steps, right? But we approximated it to a big O notation of n square, big O of n square, right? So yeah, so that's my program, and I will upload the code to my GitHub link, and I'll share that GitHub URL in my description, in the description of this video. And one more thing is, so there is a small optimization that we can do to our program. So I intentionally commented out that optimization. So at any point of this iteration and comparison, so let's say like in this iteration, like step number 13, we, in this for loop, in this internal for loop, we pass through this array and we did not do any swappings. That means actually like all the numbers are in, all the numbers are already sorted. The array is already sorted, right? So if we did not do any swapping in any iteration, it means that we have an array that's already sorted. We have a sorted array, right? So I have like a boolean variable to track that, right? So initially I have it as false. At any point if there is no swap, we just set that to true. So I'm sorry, so if there is no swap, we leave it as false, and this internal loop will get executed only if the swap is true. So if the previous iteration, if swap was done, the swap will be set to true, and then so this iteration will check if the swap is true. If it's not true, we're not going to execute this. So we're basically going to uh, stop the iteration and then and come outside the for loop actually, right? So this one is helpful if we have like a somewhat sorted array, right? Let's say like if we had the same array, I just I'll take that array and I'll sort it. I'll sort some portion of it, right? Say 32 here or 80 here. So 87, yes, 87. Or I'll just let's say, so we know that like now these three numbers are sorted, right? These three numbers are sorted. So we probably don't have to do the all the 21 comparisons like we did in the in the previous case, because the previous case the array was not sorted, like so at least some part of the array was not sorted. So I ran the same program with a sort of like a different, like a semi-sorted array. You can see that now this time we stopped with step number 15, so we only did 15 comparisons. So So this is obviously, so this yeah, this is sort of like an optimized bubble sort. And of course the worst case, we're always going to be doing n square, big O of n square. And yeah, that's it. So that's one little optimization, that swap. So we keep checking if there was a swap done in the in the previous iteration. If there was no swap, that is sorted, we quit. So that's the optimization technique that we are using here. And one last thing is actually, I'll just say one thing about space complexity. Space complexity here is basically we're not using that much memory. In any other language, we would be using another temp variable. So the space complexity for this program is big O of 1. Right. Anyway, all right, guys. So that's bubble sort. That's the end of this video, and I'll see you guys with another video